we have the last speaker for the day before we jump into blockchain and updates on that. Let's quickly go ahead and share the screen. Yep. Perfect. We have Anto from Eigenlayer. Anto, are you here? Perfect. Round of applause for Anto. Anto will be talking about decentralized cloud. Thank you so much for joining us. You would like to connect your screen?
Yeah.
Okay.
All right. Can you guys hear me okay? Amazing. Okay. So I'm Anto Joseph. I work as a product security engineer at Eigenlayer. We recently rebranded to Eigen Cloud, and I'll tell you all about it. Okay, so who are we? We are the largest US protocol on Ethereum. I believe that number keeps changing. It goes up, we go up. So I guess we are about $20 billion right now. And we raised $250 million, some from A16C. And we have hundreds of crypto startups building on us right now, and we do provide ecosystem funding. So if you are a builder that is interested in building verifiable things on Ethereum and Eigenlayer, reach out to us. So why build unstoppable verifiable systems, right? So just looking at what we have today, we started with Bitcoin, that is unstoppable verifiable money. So there is only so much Bitcoin that there will ever be, and that is what makes Bitcoin work. And Ethereum added computation to the blockchain, and that became the world computer. So the smart contracts are the secret sauce to making verifiable applications, and of course the blockchain behind it should also be decentralized so it can be unstoppable. And now these programs can hold capital like tokens, right, or NFTs. And we have DeFi. So that is unstoppable, verifiable finance. So if you look past all the multi-sigs, if you write a smart contract like wrapped ETH, for example, you send it ETH, you always get wrapped ETH. You can verify that. You don't need to trust anyone. So unstoppability, as I earlier alluded to, needs permissionless nodes. So you cannot build unstoppable programs on blockchains that can be censored. So if you let random people run your blockchain node, they could just like turn it off when it's not favorable for them, right? So how do you make it permissionless and still have trustworthiness? That is why you stake Ethereum to run a Ethereum node. So you have something at stake, you have capital at stake, and there are rules you need to follow. And if you do, you get some reward. If you don't, you get slashed. So with this system, with the stake holding you accountable and giving you rewards, you have a decently decentralized, unstoppable blockchain. So here is a depiction of where we are going with Eigencloud. The throughput of the blockchains, right? Like as you have different trade-offs, and different trade-offs gives you different properties. So Bitcoin just does one thing. You can send back and forth like Bitcoins. And Ethereum tries to be incredibly decentralized and is the base layer for all the L2s. But the bandwidth of Ethereum is not optimized for broadband scale, if you will. And then we have Solana, which is mostly hosted on big data centers and likely believes in hardware acceleration. Like as the hardware gets better, maybe the throughput gets better, and cutting edge networking. So they optimize for different reasons, different goals. And now we have Eigencloud. So what Eigencloud tries to do is, we are bringing the verifiability of Ethereum into the Web 2 world. So imagine you write like programs with maybe traditional programming languages, like Web 2 programming languages, like maybe Go, Rust, Node.js, or whatever. You cannot deploy that to a blockchain today. But you like the verifiability that the blockchain provides. So how do you access the verifiability of a blockchain and the capital of the blockchain without making the trade-offs of writing your logic in a smart contract? There is a lot of things you can do with smart contracts, but there is a lot of things that you cannot do with smart contracts. And I'm sure we are all hyped about AI. Almost everyone here, I would imagine, uses some AI. And this also alludes to this problem that we are trying to solve. Blockchains are unstoppable computers, but if we get to like this AGI, you can't even tell what is real and what isn't real anymore, because if an AI is that good, what do you trust? Like, you can probably see this on Twitter today. You see some video, you probably don't know if it is real or not. And do you really have the time out of your busy day to like verify if this was AI generated or not? It's going to be at that point where you cannot just like look at someone's fingers and tell it's AI or not. It's just going to get better. So we need verifiable everything. So social media, like what the content on your social media, is it actually true or is it just AI generated, right? So we need verifiability. So what Eigencloud tries to be is the AWS for crypto. And to make verifiable apps, you need many verifiable services. So you might need like TLS notary proofs. Like if you are familiar with CKTLS, right? It allows you to prove cryptographically that you got an HTTP response from a web server, and you can use that proof inside smart contracts because it's cryptographically verifiable. AI agents, we can talk about all these different components, but essentially you can think of Eigencloud similar to how AWS is for Web 2. And this is what I was talking about. You can run any sort of compute on chain. That is the beauty of EigenCloud. So if you have some logic, you maybe containerize it, and like you can run it on some TEs that's available with EigenCloud. That is like the lowest friction a developer can get by going from a Web 2 sort of experience to like Web 3. So now with Web 3, you have this container that is running your application logic, and the TE attests to the computation. Now someone like me who would not believe a random database and an application can believe that this application will do the right thing because there is a TE proof associated with it, and you can hold the developer accountable with staking. So earlier we discussed that the permissionless nodes cannot be held accountable unless they stake their capital. Because if I can join a network permissionlessly, I can also leave permissionlessly, and I have no repercussions if I do something malicious. So it's not just permissionless, it also requires staking capital. So the operators that run these services on Eigencompute either have put up capital themselves or have capital delegated to them. So if they do something wrong, you know that you can like slash them, and you can use that money, like maybe redistribute it to the harmed parties. It's very much like insurance, if you will. So now we have like a way to like run compute from Web 2, containerize it, and still have access to like the good things from Web 3, which is trust and accountability and even insurance. So why build crypto apps, right? I don't think I need to sell you guys on like why you should, but it's an incentive layer because staking capital to this cost gives you reward. So you get to make money, you get to build decentralized apps, and it's also verifiable. So it's not just trust me, bro, right? Like it's openly verifiable. And we believe that the total addressable market of any service, financial service, will be higher if it is verifiable. So we see this with like Bitcoin, right? Like people rally on Bitcoin because it's verifiable that there is only ever 21 million Bitcoin ever. Gold isn't like that. You can dig up more gold. So, when the demand is through the roof, maybe it's more profitable for me to like figure out how to mine gold and like just dig it up, right? But you cannot do that with Bitcoin, so probably better. And a lending platform. Imagine I'm right here and I have a smart contract. I'll be like, you guys send me money, I'll just lend you tokens or whatever. I'm going to get wrecked if I just give out money like that, because I have no guarantees that maybe some of you will give me the money back, but not everyone would, I think, right? So there is no accountability here, but Aave has this over-collateralized lending model where you put up some capital, like say Bitcoin or whatever, and then you can lend a certain amount of dollars against it, but there is a value, like maybe you are able to take a loan up to 80% of your collateral, right? And you get liquidated, and there are mechanisms to protect the lending platform. So that's how Aave works. Similar, Poly Market helps you find the free market odds of any event. And so we also have staking. We have about $20 billion in stake. that will secure computation run by about 2,000 operators, and we have about 200 plus services live right now. And one of the core things that we are building out is AI agents with wallets. So today we have some developer with their wallet running an AI agent in possibly their EC2 instance. The problem with this, you can possibly see that like the developer owns the wallet. It's not really the AI agent itself, right? Like the AI agent has access to a wallet that the developer also has access to. So it's kind of trusting the developer at this time. Same with the Stripe API. If the Stripe API says no, that's it. That's the end of your business. And yeah, I don't think we are very interested in that. The verifiable on-chain agents are actually possible. You could really run a lot of computation inside an EVM, but it's very limiting. EVM has gas limits, and it limits the computation that you can run within a smart contract. But it's just not practical, so we cannot really do that. So what EigenCloud allows you to do is that the staked nodes, the operators, run the AI inference. The data is made available on EigenDA, and the verifiability is enabled by this component called EigenVerify. It uses economic security, and this is what really makes it tick. Like imagine you asked this AI a question, it responded with an answer. You ask the AI again the same question, it should respond with the same answer. Right now, if you do that to ChatGPT, it's going to give you different answers because there is no determinism. So we have figured out a way to make some of the open source models deterministic. So that enables this. You can ask the same question multiple times, it will respond with the same answer. And if it doesn't, you can slash the operator that runs these models because they are lying. You need determinism, and that is something that we provide. We also enable applications in rollups to like consume this. So the verifiable AI agent needs more than just that. There is a ton of things AI agents need to be fully sovereign, right? It's not like keys in my computer. It's something that the agent itself can hold in a cryptographically secure way, where the developer cannot just rug their users, right? So that's just one thing. But running the inference, verifiable inference is something that we can do today. Verifiable training is something we are working on. The data, you can see some of the labs faking benchmark results and excluding certain runs when they want to run their benchmarks because they can score better. So a lot of these requires verifiability. Otherwise, you're just like trusting someone else's claims. So we are evolving from regular chatbots to agents to verifiable agents, and you can start building these today with EigenCloud. And to summarize, right, what is it that we are really trying to do here? So we are increasing the programmability of Web3 by enabling you to bring whatever you want to bring to like develop whatever you want to develop. And we are also improving the performance of the system. Because if you were to run computation in a Nitro enclave, it's possibly way faster than running it on a layer 1 blockchain that is sufficiently decentralized. but you still get to get the best of both worlds. So that is the idea with EigenCloud. So you can do things like, fair meme coins. Like if the folks who help spread your meme, if you wanted to reward them, you can do so. And I think that's a very fair way of doing something. Yeah, like social media, right? Like if you don't want Elon to tinker with your X feed, and you want to know exactly what is being done, you can do verifiable social media feed ordering. Yeah, lots and lots of ideas here for you to like go and build. And this is what the stack looks like today. We have, if you look at the AVSs right there, these are things that you have live right now. So if you want to prove some HTTP comms, like an API call, you can use zkTLS. If you want to get some price feed information, you can use oracles. You want AI, you can use our inference service. So EigenCloud is essentially like AWS, but with a lot of services that are already built out, so you can just use them to build whatever idea you wanted to. And if you want to use AI, you can do that. If you want to use zkTLS, you can do that. So it's like AWS, but for crypto. And if you are interested in building with us, you can scan the QR code that will take us to our developer page. And if you have questions, you can reach out to me on Twitter, X, that's my handle. Thank you for your time, and hope you enjoyed it.